Industrial operations, maintenance, logistics, quality control have traditionally been viewed as unavoidable drains on enterprise resources, the internal cost centers required to keep the business moving. Many of these same organizations deploy multi-million-dollar software packages known as ERPs, or Enterprise Resource Planning Systems. Yet, despite this massive digital investment, they struggle to optimize their physical, floor-level operations. We are observing a shift among Japanese industrial operators. All Nippon Airways, for example, took its internal aviation maintenance division and externalized it, offering heavy maintenance and technical support directly to other global airlines. ANA transformed a massive internal cost center into a highly profitable externalized shared service. These companies succeed by extracting the undocumented physical know-how from their shop floors and hard-coding it into a specific digital architecture. To sell a physical operation to the outside world, an enterprise must engineer an execution management layer. We define this architecture as an asset-oriented MES, or manufacturing execution system. The primary barrier to this architecture is tacit knowledge. This is the undocumented expertise, the intuition and muscle memory held tightly by veteran workers on the shop floor. Aging demographics and severe labor shortages make relying on this undocumented expertise an agile risk. When veteran mechanics retire, operational capacity vanishes with them. Consider the massive delivery fleet of Yamato Transport. In the logistics industry, a halted vehicle equals immediate lost revenue. The network requires absolute uptime to survive. A standard automotive repair shop operates during regular daytime hours and holds vehicles for several days. Yamato Auto Works requires a 24-hour, 365-day continuous maintenance cycle to keep their delivery trucks on the road. Standard software solutions cannot bridge the gap between daytime mechanic availability and continuous logistical demand. To save the network and eventually profit by selling this maintenance capacity to other logistics firms, Yamato had to completely re-engineer the physical layout of the repair process itself. Yamato Auto Works restructured their physical environment before attempting digitization, creating a new facility model called Superworks. The core design philosophy is a one-stroke layout, inspired by aviation maintenance. Vehicles move strictly forward through a multi-stage corridor, never stopping or reversing. Forcing vehicles to move exclusively forward eliminates reversing. This removes collision risks entirely and enforces an exact, standardized amount of time spent in each bay. This physical linearity strips human variables, unpredictable movements, and random delays out of the maintenance equation. Discrete, predictable physical stations allow engineers to install standardized digital touchpoints at every single step of the process. You cannot build a scalable digital management platform on top of a chaotic, nonlinear physical workflow. Physical linearity is the absolute prerequisite for data linearity. How is this perfectly linear physical flow governed digitally? And why couldn't Yamato just use a standard enterprise tool to manage it? SAP Plant Maintenance is an event-driven system triggered by dates or breakdowns. Yamato's flow-driven system generates continuous data from physical movement. Mapped to the ISA 95 framework, tablet instructions act as dispatching, mechanic inputs as data collection, vehicle history as traceability, and dashboards as performance management. We define this distinct software layer as an asset-oriented MES. It applies the rigorous control logic of a factory floor to the lifecycle of an individual moving asset, rather than a bulk manufacturing lot. An ERP perfectly manages the historical state of an asset, but an asset-oriented MES is required to govern its real-time physical behavior. Controlling physical behavior via continuous digital data is the foundational engine for servitization across multiple industries. Daikin's Air-as-a-Service model demonstrates how this architectural logic functions within the climate control industry. Daikin shifts clients toward an operational expenditure, or OPEX model, where they subscribe to 13 years of guaranteed air quality rather than paying the heavy capital expenditure, or CapEx, of buying units outright. The technical enablers here is identical to Yamato's. IoT sensors predict faults and trigger preventative maintenance before downtime occurs, ensuring continuous flow. We see this exact scale-out in the heavy machinery sector with Komatsu's Comtrack system. Komatsu made tracking hardware standard across their global fleet. They turned raw operational data into externalized services for their clients, specifically remote theft prevention and fuel optimization. In the logistics sector, the fashion e-commerce company Zozo opened its highly efficient internal warehouse API to external brands. This shared service integrates outside inventories to prevent supply chain opportunity loss. The core product being sold is the digitized execution management layer, a system that guarantees the perfect operation of the underlying physical infrastructure. If we aggregate these case studies, we identify the shared structural DNA that allowed these companies to successfully externalize their operations. This matrix plots how Yamato, Daikin, Zozo, and ANA convert tacit knowledge into explicit IT systems, standardizing custom workflows into repeatable platforms. Fusing hardware efficiency with continuous software tracking then allows these cost centers to operate as external profit centers. This rigorous control methodology is the direct evolution of traditional factory automation, or FA, pioneered by automotive manufacturers like Toyota. The strict architectural principles of the factory floor have officially broken out of the factory. By decomposing and digitizing field operations, any physical asset management, from fleet logistics to HVAC infrastructure, can be governed by this exact same MES architecture. Operational excellence, once locked within internal cost centers, becomes a distinct, exportable product when hard-coded into an asset-oriented MES.